We welcome you to the RWG meeting. Glad that you're here today. We're going to have Sarah Vazquez walk us through how to fix some terrible requirements using the guide to writing requirements as the ways to fix these terrible requirements and identifying what rules that they're breaking, etc. And this kind of stems from, for those that are involved in the Viva Engage, Alan Hunter had started with trying to find the most poorly written requirement in the history of the universe kind of thing. So it sparked some interest and also carry over some of the webinars that Lou did on doing this similar thing. So it draws a lot of attention and looking forward to it. Our presenter today is Sarah Vazquez. She's a senior system engineer at Veoneer with over 17 years of experience in the automotive and aerospace industries. She's been a member of INCOSE since 2012 and is currently serves as the CAB representative for her company. She specializes in requirements management and system engineering processes, developing, providing, and mentoring and training within her organization. She has a degree in aerospace engineering. She has worked with some propulsion systems briefly on Orbital Sciences and then moved over kind of cross country from a travel perspective into the automotive industry, where she's performing requirements management and system development for electrical power steering systems. She has a mission to promote system engineering best practices in a way that makes it easy and intuitive for users to follow in their daily work. I think we're going to see that highlighted today. So I will hand it over to you, Sarah.
Great. Thank you so much. I'm really excited for today's discussion, and I'm hoping for it to be very interactive. So please use the chat feature throughout. There will be a couple of slides where I'll actually pause and ask for some feedback via chat and go over some of that. We can have discussion. And then at the end, for sure, we'll get into the requirements everybody submitted. There were some really terrible ones that we're going to have some fun talking about and see if we're all on the same page about how to fix these and what we can do to, in general, make requirements writing easier, better, more correct, higher quality. I think that's the goal for all of us. As far as the agenda goes, first we'll just have a little bit of discussion and go over some points about why is it so hard to write good requirements. This seems to be a common struggle everywhere I have been. I don't think I've ever been somewhere where people said it's so easy to write requirements. We barely even have to think about it. It just writes itself. So we need to dig into that a little bit and find out what's going on there. Then we'll talk about what INCOSE resources are available. So from a perspective of this presentation, since we're all in the requirements working group, I think we all have some idea of what's available, but just so that everybody has links to all the resources and maybe can share some examples as well, what they find most useful. Then we'll do a brief refresher about the requirements, characteristics, and rules, just so that we are ready to go look at the really bad requirements and have that mindset. And we'll go through an interactive example. So I've put together some requirements for a clock, potentially, or a system that can report time. And we'll go through and see some problems. And I've tried to hit on as many of the requirements rules as possible. I think I was able to break about 70% of them just with 6 or 7 requirements. So we'll hopefully get a chance to see if those are the same issues that most people experience. And we'll talk about how to improve those different broken rules. Then we'll go what I'm calling the crowdsourced discussion. This is going through all of the requirements you guys submitted, which again, some really nice ones in there. And I kind of would like to see if we're on board about trends. What are the biggest challenges we see? What are the rules that are broken most often? And see if we have any solutions. How do people catch these or fix these within their organizations or in their experience? And then how can we use some of those methods to make it easier to train people to write good requirements in the first place? So first, writing good requirements is hard. Why is it so hard? This may be a little bit subjective, but in my personal experience at the companies I've been with, these are the main challenges why it's hard to write a good requirement. Number one is experience. So this encompasses things like training or actual hands-on practice with writing requirements, or just being exposed to a lot of different kinds of requirements. Maybe you're reviewing customers or industry requirements. And so the more you see, the more you can learn and grow in your own skills writing requirements. The more you can see the bad examples, the better you get at writing the requirements the right way. Also, following, as we mentioned, the INCOSE guide for writing requirements can help a lot with the experience gap that may exist when writing requirements. Another one I commonly see is, what is the actual problem? Sometimes I think we start writing requirements before we've even really understood what's going on. For example, I've seen we've written requirements, but we never created a system boundary diagram. So we don't really have context what the system is, what are the inputs, what are the outputs, what's the operating environment. Yet we're trying to go write requirements for this system. Obviously, that's something that can lead you to fail pretty quickly. So understanding the problem before you jump into writing requirements, I think, is also one of the main challenges. Planning. This one I see mostly in terms of the resources and the timing. So when organizations go to start writing requirements, I think people underestimate how long it will take to write the requirements based on the experience level of the users involved. It could vary. A very experienced team, maybe they could write requirements really quickly if they have good processes in place. If it's a brand new team, maybe they don't have robust processes, it could take quite some time. And then the review process itself, I think, is where often teams fall short. We don't schedule enough time to thoroughly review the requirements and have the discussions to make sure that we have things like technical accuracy, comprehensive, complete. And so planning, I think, is a big thing for most organizations to make sure that we give enough time to prioritize the requirements. I think INCOSE has some good statistics too in some of the presentations I've seen where, yes, if you spend this upfront time, it does take some time. However, trying to fix a problem later is much more costly than fixing it in the requirement phase. So I think mindsets need to shift, that planning upfront for requirements, even though it seems slow, it actually will save you a lot of time later. Motivation. This one I like because I don't think it probably applies to most of us here, but I do think it is still pervasive across many industries. So motivation means, how invested are organizations in actually spending the time to write good requirements? How important do they think it is to have requirements? I've seen examples where people say, there's already an industry standard out there. I'm just going to say that I follow that. My requirements are done. Not exactly. Or they might say, I don't need to write system requirements. I have customer requirements. And that's also something that can be challenging, because if you didn't write something, how well do you really understand it? I'm guessing if you're not going to spend the time to write requirements, you probably haven't spent the time to truly understand the ones you've been given. Sometimes you don't learn until you do. And so I think there's a risk that people accept requirements from external sources thinking they don't have to write their own to save time or for whatever reasons, and they're just trying to check a box. So motivation is, how much time is a company willing to spend to put in the work to do good requirements? Sometimes you might also get the, well, we have X number of years of experience designing this product, we don't need to write things down. That's its own challenge right there. But I think, as everyone will agree, things are complex nowadays. Systems are not simple. There's many interactions. Safety is an issue. I'm in automotive right now, so functional safety, cybersecurity, these are issues where you cannot say, we have this knowledge in our brains and that's good enough. You have to have things written down clearly. Consistency. So requirements as a whole, the set may be written across time, maybe across the length of the project by different people with different experience. And so consistency can be a real challenge, that if you don't think of your requirements as a set, you might end up with some conflicts throughout the set or some gaps, and then you find out later you have to fix those. And last but not least, context. So again, as I mentioned at the beginning, what's the problem? Sometimes we go ahead and we start writing requirements without the full context. And definitely understanding that it's an iterative process, we might write a first draft of requirements with the information that we know today. Later, that information may change or become more comprehensive, and we can revise the requirements. But still, there needs to be some kind of context or structure for us in place so that we can write requirements with a good outline, if you will. So you can't write a novel without an outline. You're going to get lost along the way. You're going to forget things. You're going to have inconsistencies where the story doesn't match up. Same thing with requirements. I've noticed some chat activity, and so I'm going to read some of these out. So from Lou, good point on understanding the problem. That is one reason we emphasize the development of life cycle concept and an integrated set of needs before the system design input requirements are defined. Absolutely. Postponing upfront work that is needed results in an accumulation of technical debt. That is a great comment. And I think that's something that as systems engineers, and especially with a focus in requirements, we need to bring that to the attention of organizations. All right, from Leslie. So as more and more companies embark on digital transformation, good requirements will be even more critical. They may be distributed using requirements tracking systems or SysML models, and incomplete requirements will erode the value of the digital thread. Definitely. This is the time where you can't say, well, we knew that, so we didn't think we needed to write it down. It doesn't work like that anymore, if it ever did at all. All right, from Theodore. I've noticed that within my organization, we will just accept customer requirements as they are, and I find this frustrating. Me too. More often than not, these customer requirements are not written at the system level, but we still bring them in at the top level in the requirements hierarchy, and this causes lots of problems. Definitely, I've seen that too. One thing I like to say within my organization is that the customer is always right. They can write whatever they want. However, it's still our job to understand what they wrote and put it into a framework or context of how we want to design our system. If they want to tell me I have to use a specific software component from AUTOSAR, okay, fine, they can tell me that. However, I'm not going to write that as a system requirement because it doesn't make any sense there. My system boundary has no context about this AUTOSAR software component. So I'll put the requirement they've given or the need into the right place. All right, another one from another Theodore. I've experienced a mentality of I've read this entrepreneur's memoir and he's advocated slashing requirements as much as possible and look how successful they are. I would love to know whose memoir that is and read it myself for a good laugh. I've seen that perspective too. People think that either they have knowledge ingrained in their organization and they don't want to write that knowledge down for competitive reasons or just because they don't want to do the work because they already know it. I would like to see how successful these teams really are and how much more successful maybe they could have been if they would have had a clear picture of their system development through the requirements. Comment from Lou on part of the planning must include how the system can be verified to meet the requirement. So the method, strategy, success criteria, and the responsible organization, the cost of system verification is a large part of product development. Definitely true. That's a good point that when you're planning for requirements, really it's more appropriate to say you're planning system development and requirements is one of the first steps in that development process. Like in the systems engineering handbook, we're not operating in a vacuum. We need to think how this process feeds into other parts of the organization and to make sure that overall everyone understands what role they're playing in the big picture. Okay, I think last one on this before we move to the next slides. So this is from Brian. Different customers of requirements often have very different expectations of detail. Example, an engineer versus a commercial stakeholder. Yes, and I think that's appropriate. Ideally, I think if I were to think of a perfect set of customer requirements, I would probably want them to just say what they need. I would probably want to initially just have a conversation with them. What do you want? And just hear that unfiltered feedback before they've tried to put it all into requirements. Because in the end, the system developers are the ones who understand their system the best and should be the best position to take needs from a customer and translate them into the context of technical requirements. When other teams try to do this kind of out of context or out of experience, I find that it makes the requirements not quite as clear. So why try to do a job that's not your job? It seems like if everyone does the job at their level, so a software person is writing in the context of software requirements, not system, it seems then that's where I've seen the best engagement and the best quality results. And then in the meantime, having those discussions between the levels to ensure everybody's on the same page. But the discussions focus more on the needs, not the detailed requirements. So this is here mainly so you have a quick and easy reference of the INCOSE resources. The Systems Engineering Handbook is always great to get realigned on what activities should you be doing, including in the requirements management process. The guide to needs and requirements and the needs and requirements manual, those are really good to help understand the differences between the needs that you're getting and how to make sure they're valid and able to be performed, and then translating it into the requirements, into the technical language for your system. The guide to writing requirements and the guide to writing requirements summary sheet, those two are the basis for today's presentation. So especially the summary sheet, because as I mentioned, it's short and sweet and easy to reference in a meeting like this. When you download this, it'll look like a shorter 7-page version of the bigger guide. So what I'm going to be looking at here today is mainly the characteristics and focusing on these rules for good requirements. So you'll see when we go through the terrible examples, we'll talk about these rules. So this is what I'm referring to. This can be good for us to have as a reference while we're going through this presentation. So then for the requirements working group, we also have our INET website. That's a good resource to look for additional information and strategies about writing requirements. For Viva Engage, some of you may have already participated in there. That's kind of what sparked this whole idea for today's presentation, is a competition for writing really bad requirements. And so that can be a great place to connect with others in the community, ask some questions, get some answers. Also just to share knowledge and information. It's a great resource. What I've done here is just more for after this discussion, after this meeting, if people want to come back, so that they don't necessarily have to go grab the document from the INCOSE website. I've put kind of a summary here, but the INCOSE document is more comprehensive. In my presentation, I've only put titles of the characteristics or rules. You'll get a lot more from the summary sheet. These are here. We're not going to spend too much time on this, except just to highlight that individual requirements have certain characteristics. They have to be necessary, appropriate, unambiguous, complete, singular, feasible, verifiable, correct, and conforming. For the set of requirements, some of those characteristics are similar. So they have to be complete, consistent, feasible, comprehensible, able to be validated, and correct. So you want to make sure that your whole requirement set contains everything that you need to understand to design the right system. You want to make sure those requirements are possible and they're not conflicting with each other, so they're consistent. So putting in place some structures, maybe how you organize your requirements, maybe you group them by functionality, or maybe you group them by life cycle phase, or some way that you can find requirements you're looking for when they're together as a set. Of course, you want to be able to validate all the requirements, so you made sure you designed the right system. The next slides, I really don't think I can spend too much time on each of these, but I wanted to let you know what I did here, because I took the requirements rules, again, from that summary sheet and put them into do's and don'ts. The do's are ones where we obviously would like to make sure this happens. We want to keep this rule in mind and write our requirements to comply with this rule. The don'ts are the ones that we actually want to avoid. So things like vague terms or escape clauses or using not in a requirement. These are actually ones we don't want. And as we go through some examples, you'll see that these rules are called out as being the ones that got broken. And just keep in mind the do's and the don'ts. I think after the presentation too, this is more to be used as a reference for everybody. So I'm not going to go through and read all of these, but we'll see how they come into play. And then here's some more, and there's one more page of this. And then we're going to get into some examples. So these are really just here for information or to refer back to if we need it. Before I get to the examples, I see some comments in the chat, so I'll come in here and look at them for a moment. So yes, there's some information about copyright restrictions on the summary sheet. They're a little bit more lax. So that is allowed to be used and shared within your organization. Yes, for people who are in CAB organizations, depending on your membership, just check how many copies of the documents you're allowed to have. And then obviously anyone who has an individual INCOSE membership, you can go access these documents. I see another comment, requirements that are consciously not well defined because you maybe needed to put something down on paper, right? So it's a good idea to make sure whatever requirement you're writing and whatever time you're writing it with the information you have available, that it still is following the rules. It's still a good requirement given what you know at that time. There's another comment about defining upfront the different levels of requirements is important from top level needs to defining how far down to go for the systems engineering team. And it seems to vary a lot by organization. This is not trivial. I definitely agree with that. Having a structure in place of how an organization sees their system development process, and not just from a requirement side, but I'd say architecture, verification, all those activities, having that structure in place and having everybody aligned on what that structure is really important. Comment from Brad. In my experience, the SEs tasked with writing requirements come in after the system is already architected. I like this one. The development of the architecture should provide an initial functional decomposition. That's either not done at all or isn't passed on. Therefore, SEs are often trying to reverse engineer the functions already in someone else's brain. I have some experience with this as well. For me, the times when things work out the best is when you've got your system boundary really clear and understood. Maybe you take that system boundary and you define some basic system functions from that boundary, and those functions become the starting place for where you write those requirements. And then you'll have some additional requirements that don't fall into a functional category, maybe things on quality characteristics or some performance needs for the system as a whole. But being able to organize the requirements from something at the start seems to be helpful. It's not great when you have to reverse engineer and make the requirements fit into something that was already predefined and maybe isn't respecting any of the rules of systems engineering. For example, sometimes where really detailed software functions might be defined, and then you're told, go write system requirements for this software function. And it doesn't quite fit because it's not the same scope at all. It can be very challenging. Question or a comment from Andrew. I'd like to have available a tool, a parser, compiler, analyzer that scans the text of a requirement and returns true or false for each rule. You and me both. There's actually some tools out there, and I'm certainly not an expert on that, but there's some tools out there that can help do such checks. And I think that it's something maybe as a requirements working group we'll want to look into more in the future and see if there's any guidelines about how those tools should operate. From what I understand, many of those tools are fairly new, and a lot of the people developing them seem to be open to feedback about how their tools should work the best. So maybe this working group could have some input into that. Definitely interested in the team's feedback. So the consensus I see is that these tools could be helpful, but they're exactly that, they're tools. I don't think I've seen anyone say that there's enough maturity in any of these tools to go ahead and write all your requirements for you. So we're still talking about something that could just help improve the process, maybe go along with the rules and point out problems, but we still got to write those requirements ourselves or have human ownership of them. We'll get into the example of terrible requirements. As I was trying to think of an example that we could all discuss and get on board with, I wanted to make sure it's not too detailed because, at least speaking from personal experience, sometimes we like to get bogged down in the technical details, and I don't want that to be the focus of the discussion necessarily. I want the focus to be on what are the problems with these and how would we fix them. And this is definitely going to be somewhere we're going to go through each of these requirements and point out the problems. If you see something that I haven't touched on, or if you have a different opinion, definitely put it in the chat. That in mind as we go through each requirement. So what I'll do here is first I'll read through them, and then we'll go through a set of slides talking about each requirement individually. What are the findings and how can we improve? First requirement, time shall be reported with high accuracy always. Second requirement, the LED display shall show a time in a 12-hour or 24-hour format. Third requirement, when the system is charging, additional user features are not available. Fourth requirement, the system shall be portable and waterproof. Fifth requirement, the system shall not cause a fire if damaged by water. Number 6, the system shall have an alarm feature so that the user can wake up on time, and the user must be able to change the volume of the alarm, etc. 7, the system shall cost less than $1 if possible. I have a feeling probably you're already thinking some things about these requirements. Again, these are terrible requirements. This is not an example of what you want to do. Let's go to the first one and look at the findings. I've broken this down into highlighting each part of the requirement where a rule is broken and then giving a little bit of an example, what happened and how would we fix it. So first of all, this whole requirement, time shall be reported with high accuracy always. When do we do this? So I highlighted here both the Rule 27 for explicit conditions and Rule 28 for multiple conditions. There's no context of this. Do I do this for eternity? Do I do this when I have certain power conditions? How can I do this requirement? So one important thing here is to add context in the form of explicit conditions, such as analyze the system boundary, understand what the inputs are. So for example, are you getting a power source? Is this solar? What's happening? How does the system work? And then add these conditions into the requirements so that you know when this action must be performed. Also, for multiple conditions, something like this, I would assume you'd have more than one condition that you would need to specify to be accurate. So in that case, you can add those multiple conditions. I like to use, if the conditions are many or complex, I like to use a list format so that you can easily see each condition. And it's not a hard and fast rule, but what I like to follow is if I need to read a requirement more than maybe 2 or 3 times to understand it, I need to split it up somehow. I need to break out the phrases into ways that my brain can process them more easily. So usually that happens when there's multiple conditions, and I'll make a list. All right, next problem. Shall be reported. This one, I would say, a pretty big repeat offender I see all the time. So Rule 2, using active voice. When you don't follow Rule 2 and you use this passive voice, shall be, there's actually no subject in this requirement, if you notice. So time shall be reported, but by whom or by what? It's not clear. So sometimes this can actually lead to a problem where you've written a requirement that's not even for your system. It's for some other system you're interacting with. But because it's been written in this way, that was not made clear. And that's just a time suck. So if you're writing requirements that are not in the scope of your system, it's not going to add value to your project. In this case, the best thing to do would be to rewrite the requirement with a subject, so who or what is doing the action, or who or what has the capability or characteristic or quality that the requirement needs to meet, and then use active voice, shall, followed by some kind of verb. So if it's an action verb, like shall report or something like that. Pretty easy one, but I would say this gets missed all the time. So it's a simple problem, but it does have an impact. High accuracy. So this is a vague term. So what is high accuracy? This could vary wildly depending on who you're asking. It could be a need that a stakeholder states, I want my system to have high accuracy. Okay, that's fine, that's a need. But it's our job, again, to quantify that need into a requirement that has a measurable performance. And we have to take into account things like what technology is available. So if they want an accuracy that's not technically feasible, we have to go back and talk to them and explain that that's not possible and come up with a compromise. So the way to fix this is quantify that accuracy based on the stakeholder needs and the available technology. Next, I like this one. Always, so absolutes. I'd like to ask, can any system really always function? I think that would be a really challenging requirement to verify. This kind of goes along with the first 2 rules that were broken. Because there's no context, because there's no conditions when to do this, we really can't verify this requirement. And always is not verifiable no matter what. So when we put in those conditions about when this requirement should happen, it will help solve a couple of these problems all at once. And I see some comments here, so we will take a moment and review these comments. From Andrew, we have a comment, I'd also like a validated vocabulary for my system that includes keywords for nouns, verbs, adverbs, adjectives, etc. Sounds like maybe kind of a data dictionary type thing, and you want to know if requirements have been written that don't comply with that. Sounds like a nice idea. And then multiple conditions from Monica. So in this example, maybe could do if, then else kind of format. Hopefully run requirement doesn't go too deep though. I think with conditions, this can be an area that's a sticking point for a lot of people because we have rules about requirements being singular. And so how can you have multiple conditions? Well, the way I like to describe it is the conditions are not saying to do multiple actions. They're saying the things that need to be in place for you to perform whatever action or have whatever capability or characteristic your system needs. in that context. So conditions can definitely, as we've seen in the chat here, can definitely be combined into logical formats, as long as you're making sure your requirement in the end is still specifying a singular thought. I'm going to go on to the next slide, and we are going to talk about how we can make some improvements here. So some improvements. As we mentioned, being able to put in the conditions for this requirement would really help. So here we've written the requirement: the system shall report the current time with an accuracy of clock accuracy when the following conditions are true. So the input voltage is within the operating voltage range, and the ambient temperature is within the operating temperature range. There's many ways to write a requirement and many valid ways to write the same type of requirement. So this is not a hard and fast, this is the only option we could have written, but it touches on some key points. So number one, if we are talking about specific things and those things maybe could be understood differently by different reviewers or different users of the requirement, it's best to define these terms. And so this is actually per Rule 4, define terms. So here, the rule I usually like to follow, you are providing a signal or providing an output, I like to make that a defined term so that we can have consistency between the system boundary and the requirements themselves. So I like to use the same defined term in both places. And then if you are reporting, I'll call it parameters, if you have qualities of one of these signals, such as a range or an accuracy or something, those I actually like to put as parameters where you have them tracked with what is the value, what are the tolerances, the units, and these get defined somewhere. Typically, I define them outside of the main requirement themselves because often parameters like this are used in multiple places. Ideally, when there's a way to define this parameter once and then like substitute it in where it applies, that would be the best case scenario for parameters. So here, again, maybe there's additional improvements we might see. The main point here is specify the conditions, use defined terms and be clear, and make sure your performance is measurable. We can check that the time is being output with a specific accuracy. Someone can actually verify that. And we can check that these inputs are within this certain range so that we set up our test environment correctly to verify this requirement. I see a comment. So from Theodore, I heard an interesting story when it comes to accuracy, specifically with respect to photo finishes for horse racing. The gist is that photo finishes are not a truly accurate way of telling who is the winner. They question things like the angle and focus of the camera, shutter speed, and most importantly, did the horses genuinely start from the same area? To the last statement, they made the good point that we never photo start a horse, so how can photo finish mean anything? Right, it's almost like a sliding scale. If you don't have a single truth, like a quantifiable way of measuring something in your requirement, that can leave it open to interpretation. And then maybe you can satisfy the requirement, but maybe it's not actually what you really wanted it to do anyways. And I see some more comments about maybe the condition could be while the system is powered on, that could be a valid condition. For ambient temperature, if it's outside the range, right, we could add another requirement saying that the system should report an error. So if we're not able to do this particular requirement, the conditions aren't valid. That's definitely true. We should write a requirement for, okay, we couldn't do this because conditions aren't valid. So what do we do then when the conditions aren't valid? Do we do something? And operating environmental conditions as a system requirement itself, so it can be applied to the entire system and subsystem. This is a really tricky one. So this is a question from Benjamin. So do you suggest it would be better to list them out to every requirement they apply to? My perspective is put the condition in each requirement. In rare cases, if we've defined a requirement correctly with all the operating conditions, we may be able to use that as an established, I guess, predecessor for future requirements, but I still don't like to do that. So if we say something like, if all these operating conditions are met, the system shall transition to the on state. We could have something like that. In future requirements, we might refer to while the system is in the on state, and it's kind of a way to better manage that complexity without having to put it everywhere. However, that situation might not work in every case, so it's one way to handle it. And is it overkill to add all to the introduction of the list? Actually, that's funny because in my requirements I write at my company, we do say when all the following conditions are true. I did not put that here, and I can't really tell you why I did not put that here because I don't know myself. When you have a conditional list, I do think when you put all, when it's inclusive, or any, when any condition can apply and you do the action, I do think that is a best practice. So great feedback from everybody. Let's go to requirement number 2. The LED screen shall display a time in 12-hour or 24-hour format. Let's see what's going on here. I've highlighted a couple of rules here. The first one is appropriate subject verb. And the reason I highlighted this one is because we're talking about system in the first requirement, and we don't even really know what this system is yet. It's just something that has to report time. Where on earth did this LED screen come from? So I would say, again, when we get requirements from external sources, sometimes there's needs mixed in with the requirements, or sometimes there's requirements at different levels. And as a customer sending those requirements to us or a stakeholder, that's completely valid. But we still have to understand where those requirements belong in our context. So as a system requirement, since we have a system boundary for this time telling device, it seems premature to start specifying that the output is an LED screen at this level. And also solution free. So this system could be anything really if it's reporting time, and it should be constrained by the other requirements we have for it. Like we'll see later, we have some requirements about cost or portability. But do we really need to say so early on in the development that we're going to use an LED screen as the output? What if we wanted to design an old-fashioned watch? What if we wanted to make a sundial? We're getting too into the solution too early in this case, unless there's a valid reason. So if your customer says, I want you to make me a new smartwatch, that might be the thing that you have to design. That might be valid to put in as a requirement or as a constraint, I would say. Acronyms. So I know I've kind of harped on the LED this whole time, but acronyms are fine as long as you have defined them somewhere. So the recommendation here per Rule 37 is to have a dedicated glossary or data dictionary of some sort for your requirements where you can define things like acronyms or other defined terms. So acronyms are okay, they're not a don't, just make sure you've got them defined somewhere. Definite articles. This one, I was debating whether to include it because again, it seems trivial, but I feel like it's actually really not trivial. In this case, I think it's pretty obvious. It says to display a time. So is any time okay? So if my system breaks and it's permanently displaying the time 3:30, is that fine? According to this requirement, I'm still doing what I'm supposed to do. I'm displaying a time. Guessing that's not really the intent of the stakeholder buying this system though. When you have something like this, using a definite article and personally in combination with a defined term, again, if you have a signal or an output or some special term that you're providing, using the definite article in combination with that defined term, I often find that provides the best clarity. Combinators. Here we have 12-hour or 24-hour format. Okay, so again, we get some understanding here that we want this time-telling device to be able to report in 2 different ways. That's fine, but does this have to be, you can switch between the 2 methods? Is it that you have to show both at once? Some more clarity here would help. And again, we might be getting into a situation too where we might be having 2 different needs or 2 different things, characteristics specified in the same requirement. So we need to understand this a little bit better and see if we should split this. I want to make it clear that using the and or for me, in the active part of the requirement where you're specifying the capability, the quality, the characteristic, or the action, that's usually a no-no. So combining things there means you have more than one thought per requirement. But as we saw in the previous example, sometimes you do need to combine the conditions so that you have everything correct for setting the stage for when to do the requirement. So I just want to highlight that subtle but important difference. And then this one, again, kind of trivial, but also kind of not. So keeping in mind, you should have correct spelling, correct punctuation. There's also another one about correct grammar. These rules help because a couple of reasons. Number one, how many people got distracted when they read this requirement because they saw this typo and they saw that there's no punctuation at the end? When you are reviewing requirements or when you're trying to get people to agree on requirements, distractions like that, honestly, they're taken away from the main point. So let's just eliminate them altogether. And number two, when you have mistakes, lots of mistakes in your requirements like that, it can actually affect your credibility. So I think people, maybe on a small scale, and this isn't like we're writing a text message to a friend, we're writing a professional requirements for a system that we are going to design, build, test, and sell. So having that extra check and that professionalism can really just help make sure that people believe in you, and you need that trust whenever you're trying to design a system. Let's see what the comments are for this one. All right, so we have some comments about from Henrik. Input modes can be defined in ICDs if you want one source of truth instead of repeating it in every requirement. It's a nice, good point. From Lou, it is common to have the operating environment defined in a separate requirement. The challenge is how to communicate the requirement. For example, the system shall meet all requirements when operating in the operational environment defined in Table 1. So that's a suggestion from Lou. From a comprehensible perspective, if each requirement repeated the operational environment, the set becomes hard to read and understand the real intent of the requirements. So that's kind of coming back to that earlier point on requirement 1. Sometimes if we can find a way to specify the conditions very clearly and then make sure that we understand when those conditions are applied elsewhere, that should be a way to make sure it's clear for everybody. So another one from Lou, when using or, we must make it clear whether it is exclusive or inclusive or. So one or the other, but not both, or both options. Exactly. And I think in this requirement, we don't really know what's going on. You know, is it fine if I do 12-hour and not 24-hour? It's not clear. So using or has to be more clarified. And then a comment from Lance, this should be 2 requirements to display each format per conditions in the settings. And then Brian, time zones are often fun aspects in these requirements. Yep, your Pacific Standard Time is my GMT, I forget which one that is. Comment from Carlos, so a time could be misleading if it is implicitly intended that the reference time for a critical step of the process, but the effects shall be detected only later with an unknown delay. Yes, so I think that's underlining the point that A is subjective. So unless you really do mean A, I think you can interpret kind of as any. So if I have something that says, if A button is pressed, the system shall increase the volume. That's probably not correct because there's probably a very specific button I need to press for me to increase the volume in the system. So A leads to ambiguity. And then Brad has a comment, the or also leaves open the possibility of only displaying a 12-hour format, yes, and never meeting the expectation of a 24-hour format or vice versa. That's the issue with the combo requirement in a logical sense. Really true. Like the way I came up with these requirements, the way I improved it, I actually intended that you would report both formats based on user selection. But in the previous requirement, it wasn't clear what to do. So again, this would be somewhere you'd have to do some clarification with your stakeholders and understanding what's the need so that you can actually write the right requirements. Because we could have designed the system with the requirement just saying, I'm going to choose, it says or, so I'm going to choose 12-hour format. And then they can't sell this clock in countries where it's more common to use a 24-hour format, assuming that a clock is what we're building. Okay. And Lou pointed out that there is a rule concerning logical statements and that people can refer to that. I actually will jump into that. So Rule 15 about logical expressions. So you can use these logical expressions to help indicate how the conditions are being combined in different ways. If something is not clear, these logical expressions can help make it a little more clear. Really good points. Let's move on to the improvements for this requirement. Some of them, I think, touch on a couple of the points that people were talking about. So, and again, multiple ways to solve these requirements problems. This is one possible option, but here's some things we did to fix this. So number one, I'm making a new defined term called hour option that's going to be an input actually. So this would be something the user would select. So hour option is an input to my system. I should make sure that's defined in my system boundary. So if that hour option is 12 hours, then system shall report the current time with an hour range from 1 to 12. If the hour option is 12 hours, I want the system to display AM during morning hours and PM during evening hours. So again, this hour option for the 12-hour has some additional things going on. And if the hour option is 24 hours, then the system shall report the current time with an hour range from 1 to 24. Obviously, there's probably a lot more we could have added here, but for the sake of fixing the main points we highlighted and for the sake of time, these are the ways we've chosen to break out that requirement. And then for when we specify this hour format, we want to make sure that we're complying with Rule 33 about range of values. So making sure that we have appropriate range for the thing that we're reporting. In this case, hours is pretty easy. It's 1 to 12 or 1 to 24. All right, so a couple more comments here. Report or display. I think we could do some decision making about what type of verb we would like to use here. This actually often becomes an area during requirements reviews where I see people in disagreement a lot. So one thing I'd recommend is find the verb that your group is comfortable with, that they understand the best. And then when you mean that verb, consistently use that same verb everywhere. So I don't think this is a requirements rule necessary, fall under like structured statements or something like that. But for example, if you are going to have an action to provide something, don't say provide, send, give, deliver. Don't say it 10 different ways. Say it the same way. And then so there's a couple more points here that it looks like something like displaying something. There may be an interface if the display is not part of the system. Display how. So again, we could do some more breaking down of this requirement to really truly quantify it into the technical specification that would enable us to do this. Okay, I see more comments here. So comment from Pedro, if in ears is used for unwanted behaviors and is followed by then instead of the. Okay, so I think maybe you're talking an if-then statement, which may be valid with logical operators. It's hard to see without an example, but yes, the goal is you want to make sure there's only one way to understand the requirement wording. Okay, let's move on to requirement 3. Just so you know, not every requirement has an improvement suggestion because some of them I felt were a little more self-explanatory and they cover rules we've already discussed as well. So requirement 3, when the system is charging, additional user features are not available. All right, so this additional, some people might understand what this means, but it's better to not use abbreviations. So this breaks Rule 38. Also, if you're working in any type of global organization where you have people from different countries, different languages, don't make it hard for your team. Have a defined term if you're using it, or use an acronym that's defined if you'd like, but don't put in abbreviations that may be common in your language and are not common in other languages. This can be confusing. It can also appear a little bit unprofessional. So spell it out or create a defined term or acronym where needed. This is what I like to call a do nothing requirement. So okay, the system is charging, so none of the features are available. None of the user features are available. Do I really need to say that? I often see that people want to add requirements like this because it somehow feels comprehensive or complete to them to do so, but it really doesn't add value. So there's millions or billions of things that your system is not doing at any given point in time. Do you really need to go list all of those things you're not doing as a requirement? I would argue no. However, you should reframe the requirement that in the context you provide, so the conditions that you're going to write in there, what is your system doing? And then I think the only time it's safe to assume anything in terms of requirements is if you didn't write it, it's not a requirement. So if I've written context and said, in this context, my system does XYZ, those are my requirements. So I should not be concerned about my system doing ABC because I did not write those as requirements. Now, on the verification side, you can check, okay, the system is charging, what is it doing? You can check that it's doing the actions you specify it to do. If it does something else, then you would violate the requirement, but you don't need to explicitly write out all the things your system is not doing. So I wanted to touch on structured statements as well. In this case, as I mentioned, it's a do nothing requirement. So sometimes having a structured way of writing requirements or almost like rules or templates or formats, it can help people write things in a correct way more easily. So it's not that you have to be very rigid, and if a requirement doesn't match a template exactly that you reject it, but having a common way of writing, let's say an action requirement where you do some action, or a quality requirement where you have some characteristic or capability you're reporting. Having set structures for those can help team members write things in a more similar way and avoid problems like this. Commonality helps comprehension. Some comments here from Benjamin. Do we want to prohibit the user features, or is it simply not necessary to meet those requirements in this state? Great point. If your system is doing an actual action, like maybe it's disabling something, or the user input has actually become unavailable somehow, like the system is blocking it from being used, that is something you could write as a requirement because it's actionable. But if you're just pointing out that the other features are somehow not available, that's not really a requirement. Okay, would it be better to say the system would enter a charging state than define the state in the glossary? I think it depends. In a lot of cases, I lean more heavily towards defined terms. Sometimes, I'll admit, I can go a little bit overboard on defined terms. Usually, I like a defined term if there's some input, output, or thing that I need to always define. Like I always need to make sure people understand that's what I'm referring to. If it's not an input or an output, sometimes you can still have a defined term, but it's important to balance the use of defined terms with the understanding that you're achieving through the requirements. I've seen us go to the other extent where people might say every single thing in the requirement is a defined term, and then it becomes a little bit distracting to read. So there's got to be some kind of balance. Okay, so there's a comment from Henrik. The opposite, to clarify when a function should be available, operating modes can be important to the users of the system. So right, that's another way that you could handle this, and it kind of goes along with Theodore's comment. So if you wanted to define here a state machine where you specify what actions happen in each state, that would be more valid than just saying additional user features are not available. Also, Lou makes a really good point here that there's no shall in this requirement. So is it really even a requirement statement? This is actually a pretty common blunder, I would say, is that we mix something that must be done, that's a requirement, and then we mix something that we're just explaining to people that's really information. So it's very important to tell the difference between the two. In a requirement, we use the word shall to indicate it's a necessary thing that must be done by the system. And Lou also pointed out that in Appendix C of the Guide for Writing Requirements, there's a detailed discussion on patterns. So that's a good resource for people to use. And if you don't have patterns you're already using in your organization, you could consider looking at those patterns and defining them. One comment from Andrew that we could have a list of user features shall be disabled. And then another comment from Pedro right now. How could we set the constraint to indicate the system is not expected to be available with that condition?